Okay, coming to non-exact differential equations of the type 2 of integrating factor 2. See, if I can rewrite m dx plus n dy in this following format as y into a function in xy dx plus x into a function in xy dy. This is equal to 0. If I'm able to rewrite it like this, then this integrating factor works. What's the integrating factor? 1 by mx minus ny is the integrating factor which balances the differential equation and makes it exact. Okay. Now, usually, guys, let me give a hint. There's no need to search this type of equations, guys. Usually, if in the problem, if you can find 1 plus xy, where x and y are in not separable. Okay, they cannot be separated in sine or cos, something like this. If you are being given in log or something like that, where you cannot separate your x and y, then fix in your mind that it's going to be this integrating factor that works if the differential equation fails to be exact. Okay, let's see one example so that you understand the concept properly. Suppose if I'm being given to solve, if I'm being given to solve y into 1 plus xy dx plus x into 1 minus xy dy. The first case I've mentioned. Okay, this is dy, this is equal to 0. The first case that I've mentioned. You will also see that usually x and y are in sine or cos. And if it is like that, then fix in your mind that in case if this goes to be non-exact, then 1 by mx minus ny is the integrating factor that will work. Basically, you're able to take y from the first term and x from the second term, y from m and x from n. Okay, it's like that. Okay, this is my m. Always check properly, guys, whether the first term is dx or dy. Otherwise, you'll land up with an error. If the first term sometimes in the problem can be given as dy as well. If it is with dy, then it is n. If it is with dx, then it is m. Okay. So, m I have to differentiate with respect to x, y and check. Okay, dou m by dou y I have to do. I'll be going with UV rule. Y differentiation is 1. 1 plus xy is what I will have. Plus, otherwise I can take it inside and do. That's also fine. Y into 1 derivative is 0. Y derivative is 1. So it is x into 1. Okay. Dou n by dou x. Same thing, UV rule. 1 minus xy because x derivative is 1 plus x into minus y is what I'll have. Okay, you can just check. There's a change in the sign. So obviously dou m by dou y is not equal to dou n by dou x. Dou m by dou y is not equal to dou n by dou x. So it's non-exact. So I have to go with finding out an integrating factor. Okay. Now, clearly, as I have made a mention, if all the terms have power, same power, a degree, then I can say that it's homogeneous and proceed with 1 by mx plus ny. Since I am able to rewrite in the second case kind, so what I will do is, I'll go with 1 by mx minus ny to be my integrating factor. What does this give me? Just see. 1 by, this is m into x. So xy, okay, first term is xy plus second term would be x square y square. Okay, yeah, minus ny is what? First term is xy, minus of minus would be plus x square y square. So plus xy and minus xy goes off. I'll be left with 1 by 2x square y square. Let us multiply the equation with it and see what happens. Y into 1 plus xy by 2x square y square dx plus x into 1 minus xy by 2x square y square dy. Okay. You can check for exactness as well, whether it is working or not. I can directly check or separate the terms and see what happens. Okay. So what I'll be having is 2 can be taken common and pushed towards that side. Of course, I think x squared y squared is also common, right? 2 can be pushed that side. What else can I have is 1 by x square y is what I'll have. Plus, in the second term, what I'll have is 1 by x is what I'll have with the dx. Okay, plus. Same thing here as well. 2 I pushed that side. So I'll be having what? 1 by xy squared minus 1 by y into dy. This is equal to 0. Okay. So I can check for exactness as well. This is my m1. This is my m2. N1. So I can check for exactness. I shall do that for you because you will be clear. Okay. In the exam, I suggest you to do it. Dou m1 by dou y. This is equal to what? Only y terms I'm supposed to be integrating, differentiating, I'm sorry. Minus 1 by x square y square is what I will have. Okay. Differentiation of 1 by x term with respect to y would be 0. Okay. Dou n1 by dou x would be what? Minus 1 by x square y square. And then the second term would be 0. Here the second term also would be. You can clearly see dou m1 by dou m1 by dou y is equal to dou n1 by dou x. Right? Next what I will do, just see here. I'll directly write the answer. Integral 1 by x square y dx plus integral 1 by x dx plus. Coming to the second term, the n part should be independent of x. There's only one such term, that's minus 1 by y dy. This is equal to 0. Here I should be taking the terms independent of x. Okay. Here what I'll be doing? Integrating with respect to x, treating y as a constant. Treating y as a constant. Okay? Yeah. So, integrate and then get the answer. 1 by x squared. Integration would be what? 1 by y is anyways a constant. X power minus 2. See, I will write directly here. X power n, right? X power n kind only I'll do. X power minus 2 plus 1 by minus 2 plus 1. Plus 1 by x integration is log x. Minus 1 by y integration is log y. This is equal to 0. So what I'll be getting would be minus 1 by xy plus log x by y is equal to, I'm sorry, right, is a constant because I'm integrating once, I'll be inserting an arbitrary constant. This is how I will solve using the second integrating factor. I always suggest you to check after inserting the integrating factor, do check for exactness. That's what I'll suggest, but that's optional. Okay, it depends on examiner to examiner, right? Yeah. If you're taking a proper integrating factor, then for sure the equation will become exact. If you satisfy the criteria required for the integrating factor, like for the first one, 1 by mx plus ny, it should be a homogeneous function, should be homogeneous. For the second one, you should be able to rewrite it as a y into f of xy plus x into f of g of xy kind. If that criteria are satisfied, then you can blindly go with the equation being exact and directly writing the solutions without any errors. Okay, let's do one more problem in the next video.